Alright, here we go. Got good news and bad news on this. The bad news is this is kind of a yucky problem. Good news is not going to have to do too many of these by hand, because I just want you to get a good understanding of how it works, and then we're going to be using our calculators on problems like these for sure to take care of the messiness of this. So we got violent crimes include murder, forcible rape, robbery, aggravated assault. Following data represent violent crime rate by state plus District of Columbia, so we know we've got 51 pieces of data. If 13 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. Okay, well, if we want to find if we want 13 classes, well, let's figure out what's the highest and the lowest score to see how wide it is. So let's see if I can locate here the highest and the lowest, and I'll probably look through here real quick. So it looks like this might be the highest. Oops. And the lowest. Oh no, there's the highest, 702. And then the lowest, is there anything? Look, I'm asking you as if you're going to answer me, right? 119. Oh no, I know you guys are all jumping out of your seats. No, there's one that's bigger. Don't worry, I will get there. I won't make any comments as to where these things might be, or what states, although that's probably like Michigan where Detroit is or something like that, right? Sadly. And then the lowest one I saw 119. And it looks like that's our low boy. Okay, so we're going to look at 1345.9 minus 119.8. So I've got 1345.9 minus, so that's going to be 1226.1. I want 13 classes divided by 13. 94.3. Okay, so 94.3. So remember what happened last time when I round up too far? Sometimes if you round up, especially in smaller sets of data, you're going to maybe lose a class. So you kind of have to be careful of that. In this case, since the data is so big, I don't think we have to worry about that. So we're going to go ahead and round up to 95. And 119. So an appropriate starting place, let's go down and start at 115. Okay, so let's start at 115 and a width of 95. Now I start at 115 instead of 119.8 because then adding 95 to every one of those is going to be a real dog. And if I do 115, then adding 95s is going to be a little bit easier. Okay, so let's make a frequency distribution and go from there. I'm going to start it and then I'll do it off video and then or pause it and then go from there. So if we start at 115, this is crimes per 100,000, so crimes. So 115 plus 95 is 210, plus 95, 305, plus 95 is 400, 495, 590, just adding 100 and subtracting 5, 690, 685, 780, 875, 970, 1000. 1165, 1160. I've got to get all the way to 1345, right? 1255, 1350. And that's going to cover that, isn't it? 1345. How many classes do I have? I've got, counting in between here, 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13 classes. That did the trick, didn't it? Okay, so now we're going to do counts. And then we'll do percents. Okay. So, counts. Alright, so I'll do the first one here and then the rest will go off. Alright, so between 115 up to but not including 210. 115 up to but not including 210. Let me get rid of these guys. Maybe I want, there we go. So 1, 4. So I got 5. So I'm going to do a tally marks, because then if I have to add one later, it's easy to do. So pause and we'll finish this off. Okay, here are the summary counts. Now, this frequency distribution is not like the last frequency distribution where we were able to count how many of each piece of data we have, because we only have one count for each piece of data. This frequency distribution is how many are in each class. So I went ahead and wrote the class limits here, like you saw before, and then these 5 are the 5 from 115 up to 210, but not including 210. So that would be this first class. And then the next class is 210 up to 305, and so forth, is how I made this distribution. So then a relative frequency distribution will be just the percentages of these. So I know there's 51 in here, so this would be 5 out of 51. Which would be 9.8%. And this is 16 divided by 51, which is 31.4%. And then 7 divided by 51, 13.7. Let's do this real quick. 17.6. 5 again is 9.8. 7 is 13.7. 1 divided by 51 is 1.96, which is 2.0, and 2.0%. Okay, and again, because of rounding, not quite 100, but it'll be close enough. Make sure we're all on the screen there. Yeah, there we go. Okay, so there's our frequency distribution and relative frequency distribution for data like this. Now we want to make a frequency histogram and a relative frequency histogram of this. That part of it I think is pretty straightforward, and then describe the shape of it. So I'm going to go ahead and slide over here. Now that we have all of our data, we can go ahead and do this. So again, like last time, I'll just do one of them and then let you do the other. So this is going to be counts. And looks like my highest count is going to be 16, so we'll go up here to 20. We'll do 10, 15, and 5. And then this is number of violent crimes. This is important that you say per, is it 100,000? Yeah. Per 100,000. Otherwise it'd be very deceptive. So we're going to go with 115, 210, and just go on over. Yes, this is tedious. So we don't spend a lot on this, but enough to really get a handle on what's going on. $685. 760, 1255, and 1350. And I know there was 1 on that last guy, so I'm going to get that in there, right? Okay, and then 685 to 780. It's also 1. Just back up. 590 to 685. Oops. Sorry, don't know why it did that. Okay, so 590 to 685 is 1. I'm sorry, 685 780 is 1. 590 to 685 is, we got over here is 7, right? Knowing that this is 5 right here. Then we got 5 and the one right before it. And then 9. And then 7. And then 16, and then 5. Okay, so there we go. We've got this interesting graph here, and by the way, if we if we change it to relative, this would go to percents, and this would go up here to 100% up here. You would change your scale, and then you would write percents, here, and so forth. The graph would look essentially the same. The last question is, what's the shape of this? It's real easy to want to say, oh, it's skewed to the right, and it's skewed to the right in that sense only because you have this high one here. This one really needs to be up here for it to really kind of go downhill. I mean, it kind of is a little bit, so it's slightly skewed. It's not your typical strongly skewed. It's only because you have this. So for sure it's unimodal. At this point, if you called it skewed, I'm okay with that. But just recognize, just because I put one big tall one doesn't mean that it's completely skewed that way. It does start to tail off a little bit here and here, but this is an outlier for sure. And we don't have a tendency of it all going down this like that. Does that make sense? Okay. Because if this was lower, say this was right here, then it would be almost uniform, wouldn't it? So there really isn't a one-word-fits-all description of the shape on this one at this moment in time. So go with that right there. All right, there you have it.